So simple sequential logic with one clock example. You see, as soon as clock will come and clock will come here, so it will sample at the value of D2 into Q2, and it will sample the value of D1 to Q1. So right now they are not assuming that they are assuming that there is no delay of the gates as well as your registers. Okay, so in that case what they will do, so as soon as passage of clock will come, this value will come here and this value will go here. Okay, now this output value which is sampled from input during first passage will at 0 time it will come at D2. Okay, similarly at 0 time this D2 will come to Q2. Means you are not modeling in RTL right now, you have not modeled any delay. Okay, so it is a simple sequential logic with one clock. Fine. So what is that they are talking about? But in real world, when you're using the same circuit in real world, definitely your AND gate, your OR gate, your flip flop is having some delay, right? In that case, it is not possible to propagate the signal within 0 delay time. Okay, in simulator we are mimicking that thing. So 0 delay RTL model for simple sequential logic with one clock. So they are telling they have taken example of one sequential logic block, and after that they are explaining that thing. Okay, so what they are telling is, first they are taking output as Q2, input as A, B, clock and reset. Okay, and reg Q1, D1 and D2 are the two inputs. Fine. So always at A or B or Q1. Okay, begin D1 equal to A and B and D2 equal to D1 and Q1. Okay, so what they are telling, see this is an combination block. Okay, you see the example, they are modeling this thing. So A, B is an AND operation and D1 is your result, right? D1 is equal to A and B, and you see an XOR gate, an OR gate is there. D2 equal to Q1 and D1 they are using. So D1 and Q1. Okay, so you see the sensitivity list. So they used A, B and Q1. They have to use all the variables that are on the right hand side of the combination circuit. So A, B, D1, Q1. But you will see that they have not used D1. Why? The reason is because D1 is only evaluated inside the combination block. Okay, so whenever there is change in A or B, you will find a change in D1. Okay, so no need to write this in sensitivity list. Again, either it will not create problem, but again it will re-trigger the block whenever there is a change in D1. Okay, so it will simply reduce the simulation efficiency. So it's better you should not include that D1 inside the sensitivity list. Okay, so that is what they are talking about. Second, you say one sequential block is there, always at passage of clock or negage of reset. If reset, they are assigning the output to some known state Q2 and Q1 0, and else they are assigning the value of D1 and D2. So this is, you have not seen any delay in this sequential circuit as well as the combination one. So this circuit is a combination of sequential and combination, but with 0 delay.